Number 6 says, which set shows all possible rational roots of this function? So to test the possible zeros, to list the possible zeros, we actually look at the last number here when the coefficient in the front is 1. We only look at the last number. So what are the possible factors of 24? The factors are plus or minus 1, because 1 times 24 is 24, so 1 and 24. And plus or minus 2 times 12, so that will be both 2 and 12. Next, 3 times 8 is 24, so it's plus or minus 8, and then we have 4 times 6 also. So those are all the possible zeros. Next, we're going to proceed to find the roots of the function. So we're going to use one of these on the list to actually test the roots. So we're going to continue on the next page. So we're going to start by setting up the synthetic division with the coefficients, which are 1, 1, negative 14, negative 2, 24. And I have a good feeling that 3 might work, so let's test that out. And first step, bring down 3, bring down 1 multiplied by 3, we will have 3. Combining, we have 4. 4 times 3 is 12. Combining, we have negative 2. Multiply again, we have negative 6. Combining, we have negative 8. Multiplying by 3, we have negative 24. And sure enough, we have a 0. If we were to rewrite this, the first thing we do is write down the factor, which is going to be x minus 3, since that is what's going to yield a 3 for the root. Next, we're going to reduce all of the power. Since the problem started with x to the 4th, we will need to reduce it by 1, so we will have x to the 3rd plus 4x squared minus 2x minus 8. So that would be what goes into the factor form. And since we're going to continue to look for the zeros, we can go ahead and continue using the same method that we have, and we're going to now look at this factor right here and test the possible zero. So again, since the coefficient of the first term is 1, the possible zeros are going to be coming from the last number, which is 8. So based on 8, the possible zeros are now plus or minus 1, 2, 4, and 8, which means the zeros, if there are any, will be from this list. And I have a pretty good feeling about negative 4. Let's test that out. We're going to use the new coefficients from what we just found, the leftovers from the last problem that we did. We have 1, 4, negative 2, negative 8, because we're looking for the roots of this new factor right here. So we're going to use the new set of coefficients. So first step, bring down 1, to multiply, we got negative 4, and we have a 0. Multiplying 0 times negative 4 will be 0. Combining, we have negative 2, and negative 2 times negative 4 is 8, which will give us a 0. So we're going to now write down the new factor, which includes what we have from previous step, which is x minus 3 from the first time that we found it. From this one, we just saw that the root is a negative 4, which means in factor form, it will be a plus 4. And then we have reducing the factor, it will be reducing it by power of 1, we have x squared plus 0x minus 2, which just means x squared minus 2 is what is left. And setting it equal to 0, we now will proceed to finish solving the last factor for 0. So we're going to set x squared minus 2 equal to 0. From here, we can actually pretty easily solve this quadratic, which means add 2 to both sides, and we will have x squared is equal to 2. And then the last step is actually take square root of both sides. So we have x equals plus or minus radical 2. And combining from the previous roots, we have x equals 3 and negative 4. So that is the complete set of rational, those are the zeros for the function, which gives us the answer choice of A, looks like. So let's go back and confirm from the problem that choice A is going to be plus or minus radical 2, 3, and 4. There are a total of 4 roots because the original problem starts with a power of 4, which means there are 4 roots in this problem. So there it is.